this video. In this video, I'm going to discuss the topic on the reservoir problems, and I'm going to solve two problems para ma-illustrate ang kini na topic. Okay, so let's have a brief discussion sa the reservoir problems. So, typical na problem na ay three ka reservoirs A, B, and C. Given ang elevation, for example, a reservoir A at elevation 100 meters, B elevation 80 meters, and then C at elevation 50 meters. So, all three pipes, 1 and 2, 3, will meet at the junction P. Okay. So three reservoir problems, duha na siya ka case. Okay. And ang pinaka-critical there is B because normally, A will always give off water being at the highest of highest elevation. So, mo give off siya of water. Okay. So, and then ang C, being the lowest, will always receive water. So, ang B there ang critical. Duha man nga case. First is B will receive water or it will give off water. So, case 1 na to is this one. B receives water. Okay. So, mao na sa Q1 and then mo receive og water ang B. And of course, ang 3 will always receive water. So, ang problema lang dire is kini lang sa B. Now, sa hydraulic grade line, it's a graphical representation sa potential energy. And it is the sum of the elevation head and the pressure head. So sa A, consider the surface, not the yung elevation. Na sa kadakuan reservoir man we always assume na at the surface, of course, pressure is zero. So, ang elevation sa hydraulic grade line at A is na dire. Di ba? Or anywhere. And then sa B, of course, there is sad. K0 ang gawin ng pressure and then ang C is very good. So, ang sa P na lang. Asa ang elevation sa hydraulic grade line at P? So, two cases. It's either it is above 80 or higher than 80 or lower than 80. Dire. Oh. So, dire to magamit ang kining Q2 because ang isa sa characteristic sa hydraulic grade line is the hydraulic grade line will slope downward in the direction of flow. Always remember that one. Hydraulic grade line slopes downward in the direction of flow. So, kung sa ang direction of flow, if it is from left to right, then ang imong hydraulic grade line will slope downward from left to right. Also, slope downward like this one, left to right, slope downward right to left, right to left. Ana sa? Depende sa direction of flow. So, ang atong Q2, diri mo ta critical no. Ang flow na to sa B is left to right man. Kaya gikan to B. So, left to right. Therefore, ang hydraulic grade line going to B will slope downward from left to right. So, in that case, it is higher than 80. No? Para mag-slope downward siya, left to right. Ano ba? Okay, kung below 80 siya, then ang hydraulic grade line mo will slope downward from right to left. Slope downward man right to left. Which is not the case. Kaya nga itong flow, left to right man. So therefore, ang hydraulic grade line sa P is located above 80. So, our first equation is kini sa Q. Sa junction siya ba, entering o leaving. So, discharge entering the junction equals leaving the junction. So, Q1 equals Q2 plus Q3. O, normal nga case sa normal problem sa three reservoir is getting the values of Q. So, tulo man we need three equations para ma-solve na to. So, we need two more equations. So, dito sa grade line. Yeah. So, again, since the flow at B is from left to right, then the hydraulic grade line will slope down from left to right. Kana, no? Left to right. So, naadiri ang imong hydraulic grade line. Of course, it's lower than 100 kay di man pwede mo exceed sa 100 kay naman tayo friction loss sa pipe 1. So 100 minus friction loss, it should be lower than 100 but higher than 80. So nani imong hydraulic grade line. Ana, and then going to be slope downward left to right, and of course a C. Ana, mo ni imong hydraulic grade line. And the difference in value gikan ani na point of this one kana is our HF1 or friction loss sa pipe 1 or H1 lang pwede ra. And then ang difference pod sa hydraulic grade line elevation niya ani og 80, that would be our H2 friction loss for pipe number 2. And then elevation ani junction minus 50, that would be our H3. So ang equation na to, additional equations ani is kini H1 plus H2 equals 20. H1 plus H2 20. Difference of 180. 20. And the other one is H1 plus H3 equals 50. H1 plus H3, 50. That's 100 minus 50. Or this one, H3 minus H2 equals 80 minus 50, 30, no? Pwede ra ba? Anyway, if you will simplify equations 2 and 3 and you eliminate H1, the result would be H3 minus H2 equals 30. So kung i-apply pa nimo, i-include pa nimo na redundant. Sobra na. No? And ang expression na to sa friction loss involves Q man. So natin Q1 and Q2, Q1 and Q3. So we now have three equations with 3. Ano? So masolve na to ang Q. Okay. So ang case 2 is B gives off water. So inan is Q1 and then ang mag-give off siya o water. And then of course 3 will always receive water. So ang equation na to, entering equals leaving the junction. So ang ma-enter is Q1 and Q2. Ang mo leave sa junction is Q3. Kanal. And then again, ang atong hydraulic grade line, focus on pipe number 2. The flow is from right to left. Diba? So therefore, a hydraulic grade line will slope downward from right to left. So it should be this one, right to left. So ang elevation sa hydraulic grade line at the junction is lower than 80. Inadari. So for pipe 1 or from A na dia and then B na slope downward from right to left. Kaya ang flow na to right to left. And then natin C. And H1, this one, H2, and then H3. So equation 2 is gani. H1 minus H2 equals 20. No? H1 minus H2 equals 20. And then H1 plus H3 equals 50. Oh, yan. Okay. So let us now solve a sample problem. In the figure shown, if pipes 1, 2, and 3 have diameters of 24 inches, 12 inches, and 18 inches, and lengths of 1,200 feet, 500 feet, and 1,000 feet, respectively, determine the flow rate into or out of each reservoir. Q, bale, no? So Q1, Q2, and Q3. Use F equal to 0.02 for all pipes. Okay. Now, at first, we don't have any idea about pipe 2 or reservoir B, whether it will receive water or it will give off water. Now, pwede ka mag-trial and error. Okay. Mag-assume ka nga, assume that B receives water. Pero what if kung sayop ka, mag-give off din siya og water. Di ba? So, it's a waste of time. Taas na kayo imong agi ba? And then masayop ka sa mga assumption. Okay. So, ang suggestion na is this. This is the usual suggestion. Assume that there is no flow in pipe 2. Or simply Q2 equals 0. I-assume na mo. So, Q2 equals 0. So, if Q2 equals 0, ang head loss po niya 0 sad. Because ang expression sa head loss or friction loss involves Q man. So, if Q is 0, friction loss is 0. Therefore, ang imong hydraulic grade line, since wala mo kay head loss, level lang. Kada lang imong hydraulic grade line, same elevation 90. Kaya wala mo kay head loss sa B, asa 2. Mo ano sa? So ma-plot na nimo. Kana each one that is equal to 10, 100 minus 90, and then H3. Ang naka Q1. And then draw ka diya for reservoir C. H3 eh. And 20. 90 minus 70. Yung slope downward, right to left. So mo flow siya right to left. Okay? Now, so, mo niya ang property sa pipe 1, diameter, length, 2, and 3. So, let us solve Q1 and Q3. Since naman tayo value sa H1 o H3. Okay. Mo niya itong expression sa friction loss sa English system. No? So, with given Q and then H, with given H, friction loss, and the properties of the pipe, F, L, and D, length, F is 0.02 man for all pipes, D. Makuha na itong Q1. And also, we can solve for Q3. So, yan yun. For Q1, matay na ni H1, and then 10 man siya, equate na to. Natay Q1 equal to 23 cubic feet per second. Do the same for 3. Natay H3 na 20, kanasad. It turned out that Q1 is bigger than Q3. Di ba? Mas dako ang Q1 kaysa Q3. So therefore, B will receive water because dako man eh. Bigger man ang Q1 kaysa Q3. So it is assumed that some of the volume or some of the discharge will go to B since Q1 is bigger than Q3. So therefore, B will receive water. Ano? Now, in the case where Q1 is less than Q3, so it means that some of the discharge comes from B. Kaya mas bigger man ang Q3 kaysa Q1. So in that case, B gives off water. But in this case, bigger ang Q1 sa Q3. So ang difference sa value, uh, assumed to be going to reservoir B. So mas better ni na assumption kaysa mag-trial and error ka. No. Uh, so, mao na itong flow na. Q1, B will receive water man. Yeah. So, let's plot the hydraulic grade line. Flow is left to right. So, the hydraulic grade line will slope down from left to right. So, it's higher than 90. And then this one. Okay? And then each one, H2, and H3. So normal equation na to, discharge entering equals leaving Q1 equals Q2 plus Q3. And then head loss H1 plus H2 equals 10, 100 minus 90. And then H1 plus H3 equals 30. Okay. So let's get the expression of H1, 2, and 3. This is the expression of H. Mao itong Q1 H1, and then H2, and then H3. Okay. So, ang solution 1 is the longer one. The longer solution. Yeah. Sige. Let's combine 2 and 3. Ana. Now, for this solution, the objective here is zero ang right side and not to eliminate any of the variables. So, para ma-zero ang right side, we're going to multiply this one, the equation 2. I-multiply na to by 3 and then i-subtract na to. So, times 3 and then i-subtract. The result would be 3H1 minus H1, that's 2H1. And then 3H2 minus H3 equal to 0. Mao gini siya. I-zero ni siya. For this solution na i-zero siya. So nata H1, H2, and H3. Next is we are going to substitute this one kini dire H1, 2, and 3. Okay, may muna ito equation 4, sorry. Equation 4 and kani. Muna expression. And then multiply na 2 and 2 and also 3 muna result. Okay. Next is we're going to substitute equation 1 kining Q1 atong i-substitute dire. Para duha na lang ka variables. Kana. And so expand na ito ni. Ano yung result? And then distribute ni 0.0378 kana. And then combine like terms. 0.0378 plus 0.756. And also for Q3, 0.0378 minus 0.06637. Mano yung result. Okay. So, we can assume this equation as a quadratic equation with Q2 as our variable. And we will treat Q3 as one of the, as a constant, part sa constant. So, sa quadratic equation, our A is 0.7938. Ang B na to, since atong variable is Q2, then Q3 will be part of B. And then C, kita yan, C na siya. Constant ba? Ah, and we're going to use quadratic formula. So using quadratic formula, A, B, and then C. Okay. Mao ni sa quadratic formula. Mao na itong variable root bale negative b plus minus b square minus 4ac all over 2a. So Q3 square ma-combine na and square root Q3 na lang ang bilhin dere. And we have this. Now we only have one root kaya di mo ito pwede mag-negative. Minus niya minus. So isa lang ka root. Dire, minus and then plus. I-divide na yan. Okay. So Q2 is equal to 0.148 of Q3. This will be our equation 5. And then if we'll go back to equation 1, muna to equation 1, Q2 plus Q3. I-substitute na to ni Q2 dire, and nasa tayo Q1 in terms of Q3. This one. This will be our equation 6. Okay. So next is, we go back to equation 2. Muna to equation 2. H1 plus H2 equal to 10. And i-replace na to ang expression sa H1 and H2, this one. Kini ba? H1.0189, H2.252. Yan. Equation 7. So, kining Q1 o Q2, i-replace nato ni in terms of Q3 from equations 5 and 6. So, ang Q2, this one, i-substitute na to there. And then ang Q1 na 1.148 Q3, i-substitute na to there. So, substitute 5 and 6 to 7, we have this. And then, using your calculator, shift solve na kay Q3. And after this Q3, substitute nimo dire sa 6 na kay Q1. And then Q3 substitute sa equation 5, we also have Q2. So, mao ni ang flow rate sa tulo ka pipes. Okay. Now, kini nga solution, this is not suitable for board exam. Kay taas man eh. Oh. So, a suitable solution for board exam is this one. Solution 2 na to. Mao man yun. Q2 receives water, so mo na yung grade line. H1, H2, H3. Mo na equations na to. Same as sa solution 1. No? Q1 equations sa head losses. Mo na expression dayon sa head losses. Okay. So for this solution, that suits the board exam na style is, ato ni i-assume nga variable. Let us say x. Let h1 equal to x. Okay. So, kining h1, x na siya. So, from equation 2, if h1 is x, then h2 is 10 minus x. Diba? Ato ni transpose. So, h2 is 10 minus x. Kining h2 daw, 10 minus x na. Ano. And then if h1 sa 3, equation 3, if h1 equals x, then h3 equals 30 minus x. So 30 minus x pa na. So our next objective is to solve for Q1, Q2, and Q3 in terms of x. So what shall we do? Okay. For Q1, i-divide na to ang whole equation by 0.0189. So, Q1 squared na lang ang bilin. So, sa right side, that would be 1 over 0.0189. Di ba? Ang quotient ato, 1 divided by 0.018. Ang quotient na to, part to siya sa x, get the square root, q1 na lang, square root add na yun. So square root sa quotient, tapos square root of x na yun. Mo na yung result. So asa gikuha ning 7.274? 1 divided by 0.0189 and then square root, mo na yung result. O x naman is a square root na square root of x. And we'll do the same for 2 and 3. So 1 divided by 0.252 and then square root niya kini part ni siya sa radicand. Kana. Ang 1.992 mo siya ang square root sa 1 over 0.252. And for 3, Q3, 1 over 0.06637 and then get the square root. Mo ni siya, 3.882. And the next ani is we're going to substitute Q1, Q2, Q3 to equation 1. So from 1, we have Q1 equals Q2 and Q3. Ato ni substitute nin tulo dire. Ana. And by trial and error or using your calculator, x is equal to 8.187. This is acceptable because from the figure, x must not exceed 10. Okay, ang 100 to 90 na to, 10 raman na. So dapat ang atong each one, dili mo subara sa 10. So acceptable na sa na value, 8.187. So ang next is, substitute nimo ang x dire, 1, 2, and 3. Makakuha ka Q1, Q2, and Q3. Q1, take to Q1, 20.813. No? Rounding of errors na na. And then Q2, 2.682. 683. And then Q3, 18.131. Rounding of errors lang. But of course, part aning solution to is katong assumption na to. Na first, mo assume ka na no flow at reservoir B para ma-check nimo ang elevation sa hydraulic grade line at the junction. Kini if it is either above B or below B. And once ma-check nimo by comparing Q1 and Q3, ma-check nimo whether B will receive water or will give off water. Ma-plot nimo, ayan na dahil ka mag-assume sa X. Ma-shorter na isang solution compare atong result ka quadratic. And suitable na siya sa board exam. Okay. So, as a proof, let us solve a sample board exam problem which came out May 2015. Sa kini na board exam, duha ka problems ang 3 reservoir problem. So imagine, if you don't know this topic, 6 na kabuok ang wrong nimo. Kay duha ka problems man. Sige. Let us solve this one. 3 reservoirs A, B, and C are connected by pipelines 1, 2, and 3 respectively. The elevations of reservoir A is equal to 200 meters, while that of C is 178 meters. Okay, the discharge flowing towards B, take note towards B. Therefore, B will receive water. The discharge flowing towards B is 0.6 cubic meters per second. Reservoir B is higher than C. Properties sa 3 pipes, diameter, length, and friction factor. 1. Compute the rate of flow out of reservoir A. 2. Compute the rate of flow towards reservoir C. And then 3. compute the elevation of reservoir B. Okay. Ang given dire ang discharge sa B. So, wala elevation ng B, unknown pa. So, ang given, kine, Q2 equals 0.6. So, since reservoir B receives water, then ang elevation sa hydraulic grid line at the junction is higher than B. So that it will slope downward from left to right. Kana. Okay. So, plot na to and also for C. Yeah. So, Q1 and then Q3. HF1 and then HF2 and then HF3. So, equation na to, friction loss lang, Q1, Q2, and H1, 2, and 3. Mo ni siya, SI man so 0.0826 FLQ squared over d to the fifth power. Each one, of course, ang properties na kini. For pipe 1, diameter 0.8 meters, length 1.5, friction factor 0.0158. 0.0158, 15.8. And then H2, dito rin hapon. And then 3. Okay. Now, given ang Q2, di ba? So, since given ang Q2, we can solve for H2. Kaya na may Q2. So, since given siya, then ito H2. 2.89. Now, next is, we cannot make use of the equation of Q sa katong entering and leaving. Kaya Q1 and Q2 are still unknown man. So, dito pwede kagamit. So, what we can use here is this one. Kiling sa 200 o 178. So, dito pwede mag H1 plus H2. Okay, wala pa man tayong elevation sa B. Direta. H1 plus H3 equals difference of 200 and 178, 22. So, from the figure, yan, H1 plus H3 equals 22. Nasa. Wala tayo lain magkuha. Kini lang. And let's replace the expression of H1 and H3 by this one. I replace na to ang H1 and H3 by these expressions. Rather. Okay, so we have to announce Q1 and Q3. Ayaw na tayo mo consider ani. Kaya ang equation sa Q1, 2, and 3, inani man. Entering equals leaving Q1 equals 0.6 plus Q3. So, we have two equations, equation 1 and equation 2. And we can solve for Q1 and Q3, or we can solve the equation by substituting this one to this equation. Q1 0.6 plus Q3. Ito i-substitute there. And we have this. And then shift solve. Calcu. Q3 is 0.4112. And then after solving for Q3, substitute plus 0.6, that would be Q1. 1.0112. So, okay na ni. Letter question 1 and question 2. Third question here is elevation sa B. Okay? Elevation, yan yun. Compute the elevation of reservoir B. Okay, to compute for this one, elevation sa reservoir B, isubtract na to 20 minus H1 minus H2. Mo na elevation sa B. Pero wala pa man tayo H1, ato sa ning kuhaon. We will now solve for each one since we already have the value of Q1. Ano naman tayo Q1? Okay, so solve for each one. This one, 6.1088. So pwede na tayo kuha sa elevation sa B. Elevation of B equals 200 minus each one. This one, 6.1088 minus each 2 na 2.89. And the answer is 191.0012 cubic meters. Cubic meters, sorry. Meters elevation. Okay. So, that's it. Thank you for watching.